Hi there, my name is Ron Rogers, and I'm going to tell you about our flight test with my committee on the 777-300. I was chairman of the Alpha National New Committee, and I'll explain that in just a second. But some of you may be familiar with that. But I flew the 777-300 in flight test on April 2nd of 1998. Didn't make captain till September of '03, so my heavy experience was limited to co-pilot on the DC-10 for about a year and a half and a little bit of time in a KC-135 in flight test. So not a terribly experienced heavy pilot, and I'll tell you how that was kind of a little funny thing here in just a minute. Also, I became a line check airman on the 777. They wanted you to have 3,000 hours. I had about 2,500, and they asked me at that time to be a line check airman. Now, it was a little short on the time at that time, but it was kind of funny. The flight manager who brought me in says, well, we have to conduct an interview, but you're hired, because he knew about my background and everything. But I should have read my report in the Airline Pilots Association magazine, because I got one thing wrong, and I told all my students and I told a few of my co-pilots something that was an error, and I apologize for that, and I'll cover that in just a minute. But let's talk about the flight test itself, and let's talk about the aircraft just a little bit. All right, so there we are. We're getting ready to go fly the Boeing 777-300. You can see it painted in the aluminum up there. And that's me at the top left, the committee chairman. And I had the greatest group of people on my committee. Because we were doing the flight evaluations and we've been doing them sometime, I could select some really great people. In fact, I need to do a video talking about some of the people I had to turn down. And I mean, they were just extraordinary people. And I felt so bad that, I could only have so many slots and stuff like that. And they were full. And there's political stuff. I won't go into that right now. But, I could only bring so many on. Well, okay, let's talk about Steve. Steve was a first officer for Delta on the 767 at the time. And I knew Steve back at Test Ops and that at Edwards. And he had become the F-15 Strike Eagle program head out there at Edwards, and he was also became the vice commandant of the test pilot school. So Steve knew what he was doing. Next to him is Joe Kohler. Joe was my heavy guy. No weight thing here. Joe was a long-time 747 captain, instructor, and stuff like that. So he had a lot of long-range heavy experience, and he was my ringer that I brought in. Next to him is Terry Lutz. Now, Terry was out at Edwards shortly after I was, so we kind of just passed. We just missed each other. Let's put it that way. But he was an instructor out at the test pilot school, and he was a former project pilot for Kelspan Corporation, which did a lot of the, they developed the flight controls for the stealth fighter. They did a lot of work for Boeing on developing flight controls because that was their simulation ability. So he had a lot of experience with that, and actually he took over the committee from me. Next to him is Frank Santoni, who was the chief test pilot on the 777-300 program. And next to him, of course, is John Cashman, who was head of flight test now. He had been head of the 777-200 program, and I flew with him a number of times there. But, okay, I was, at the time, a member of Society of Experimental Test Pilots. Steve Stowe, next to me, was an associate fellow. He later went on in his various work, became a full fellow, just recently, actually. Joe was not a test pilot SCTP member. Terry Lutz started out on my committee as an associate member. And this I found amazing, that a guy who was an instructor at the test pilot school, the best he could do was associate member, because you have to do actual flight tests. So that doesn't count enough to get you past associate, which is kind of the entry level at the time. But through the work on the committee, he got to be a member. And then, of course, he went and worked for Airbus, and one of the first flights he did was on the 380. So he became an Airbus test pilot and became an associate fellow and then a full fellow. So these guys did very well, advanced very well through the structure, and of course were just an incredibly great asset for the committee, gave us an incredible amount of credibility, because before then, a lot of the people, it wasn't that great of a committee. They weren't doing much fun stuff. They weren't flying any airplanes virtually. So it wasn't attracting people. But now, once we really got into the work, we were attracting good people. And I'll tell you, it made for a great committee. Unfortunately, I do a thing about the rise and fall of the committee. I don't think, I'm not sure they have hardly anybody with that sort of background on it now, but okay, enough of that. Now, the committee, it went around and had various changes and iterations and things like that. So at one time I was chairman of the Alpha National New Aircraft Committee. Then I was director of Aircraft Performance Evaluation and Certification. What we did was we combined the New Aircraft Committee with the Airworthiness and Performance Committee into one we called APEC. And then that's my upper right is my Boeing flight test card when I was furloughed and worked there, and then of course the International Association of Airline Pilots. I was also a member of that. Now, when we would go out for these flights, we would get a very thorough briefing, and I pulled some stuff out of it of interest. This briefing package is about a quarter of an inch thick. There's an awful lot in here, and we get very thorough briefings. Now here's the 777 family, and I like that. The 777-300, fly more people and provide more value. The 777-200 is provide more value. Okay, this is marketing people here. They got to say something. And then the Dash 200, increase gross weight, fly farther, and provide more value. Okay, now the 777-300 is a derivative of the 777-200. It's stretched about 33 feet. Okay, here's a picture of the aircraft. This was in our briefing, and it's 30 feet longer, allowing it to carry 20% more passengers. Maximum takeoff weight of the Dash 300 is 660,000 pounds, with 98,000 pound thrust engines. Maximum landing weight is 524,000 pounds. This is all at the time, and there's, these things can change over time with gross rate improvement programs and stuff like that. And an interesting thing is the cameras, and I'll talk about those. They have two mounted on the horizontal stabilizer there, and one mounted behind the nose wheel. And that was a new addition. It was kind of cool. This is a long aircraft, so the cameras. And I'll talk about those in a minute, were very interesting. But the one thing Boeing always did, which is really funny, is we would have a briefing and they would talk about the various configurations, and it's they've got here's the various information on the baseline and the 10 frames here and the frames back here, in the back, 9 frames in the back, 10 frames in the front, how much it was stretched. But the interesting thing is they typically quoted what for the normal airlines, which were 3 class type of passenger setups. Okay. They would pull out a slide always for fun, because in Japan they take airplanes like the 747 and they fly it just between points in Japan, because they move a lot of people short distances, but they need big airplanes. So their configuration, and the Japanese people tend to be a little bit smaller and they have shorter seat pitches. They would always throw up a slide where, okay, yeah, you guys have it configured for 284 or 300 and something. Well, how about 550? Because there is no first class. It's all one class. It's not a terribly long flight ever. So, you just cram the people in and go. So, kind of interesting. Oh, and here's another slide you'll like. If you want to put people in, if you want range, we got an airplane for you. We'll just give you whatever you want there as far as range, and we got an airplane to fit the bill there. And then, of course, they talk about what they do to increase the range configuration, how they extend the wing fuel tank. They strengthen the wing, obviously. And they talked about a tank in the aft cargo compartment. And one of the funny meetings with John Cashman, they talked about if you had to dump this fuel out for any reason, like you had an emergency. And he says, well, make sure that you dump it into the main tank, not out the back. Yeah. Kind of interesting, and it could go up to 102,000 pounds of thrust. Now, that's a big engine. Now, And here's a little bit more information about the 300. Vertical fin, they were adding a tail strike, a tail skid, not just a tail strike indication, but a tail skid, because they thought the chance of a tail skid could be more likely, and I'll talk about that in just a minute. But the 777 that we actually flew was the number one 777-300, and it had about 500 flight test hours on it. And at the time we took off, we weighed 501,000 pounds, and 163,500 pounds of that was fuel. We were also using the Rolls-Royce Trent 892 engines, and they were rated at 90,000 pounds of thrust. And they had three spools. They had an N1, an N2, and an N3. And that was kind of interesting on start to watch those engines spool up. But I'm going to throw some extra pictures in here I think you'll enjoy. As you know, they have to do a strength test, and that little yellow arrow points to this is the static test, and that shows how much that wing can actually bend before it breaks. It can go up to a pretty high value there. Of course, when it snaps, it's quite dramatic, and you may have seen some of the videos on that. Also, flight test aircraft have the ability to change the center of gravity for doing various CG tests, which of course are necessary for certification. And they have to do a BORT test, and you notice those carbon brakes can get rather high and hot. And here's a picture where they do VMU, minimum unstick. They get a speed that they use for a lot of calculations based on the absolute minimum airspeed the aircraft will come off the ground. And I've never done one of these tests. I hear it's very interesting and actually quite difficult to do. Because it's not a natural pilot thing. I'm sure there are plenty of pilots out there who have scraped the tail on takeoff unintentionally, but you try to do it in flight tests like the 10 foot per second landings that I did. It took me 3 tries to get that right, because although I could do it on commercial service, plunk one in, trying to do it on purpose was a lot harder. And of course, it's a very good position to be as the photographer there, unless something goes wrong, of course. And there's a picture of doing the VMU unstick test with the tail on the ground just as the gear come up. And there's a picture of the protective devices they have on the tail there when they're doing this test, so they don't have to reskin and do damage to the airplane each time they do this test. And of course, they have to do water ingestion. You want to make sure that when you take off through water, or you land through water, that you don't flame out the engines by throwing water in. Actually, it's quite difficult to flame out an engine by throwing water in it. And I digress here. Now, I know people, they're waiting for the digressions. And if I do one of these and I don't digress, I know there are people that, they'll comment, they're upset, so... Okay, we got to have the digression. So here we go. We had a helicopter that was trying to do determine the minimum auto rotation speed and altitude, and he determined a point past that. The aircraft crashed out at Edwards. Nobody was injured or that, but the rotors came down, chopped off the tail, and the blades just disintegrated. Well, they decided it was good to get out, so they got out of the thing. But I guess there was an issue. They couldn't shut off the engines for some reason due to the damage when they hit. And the fire department tried to just spray water in the intake. You think, well, you spray water, you'll flood out the engine and it'll quit. They had one heck of a time of spraying water in the intake to get it to quit. So found out that it's kind of amazing, but these things can ingest a lot of water before they get upset. Now, here's the article, okay? I made it. They mentioned me on the front page, which is nice. Actually, number 1. Okay, it's a big airplane. A lot of pilots like big airplanes, so I guess that's why it's going here. And I'm actually number 2 on the list. Hey, instead of being at the bottom, of course, they're not saving the best for last. I'm up here in the front, so that's nice. And the editor people, they do a very good job here. My wife, I have to give her credit. She proofreads my material because I can spell a word so badly that spell checker can't recognize it. Okay, that's when you're spelling pretty bad. So she reads for clarity, and so when it goes actually to the Airline Pilots Association editors, they really don't have to do too much at all, fortunately, to make it work. So here's the article, and I'm going to put a link to this article, a PDF file, so you can download it and read it at your leisure. But look, they put that nice little picture there. They did the same nice job on the C-17. Did a nice full spread on the picture there. But I mentioned these cameras that were in behind the nose gear and on the horizontal stabilizer. It was kind of interesting. The image was very clear. They said they had a lot of problems keeping the lenses clean. They had to go through a lot of work to find a method that worked to keep them clean. But the image seemed to be a little dim in direct sunlight. But Captain Santoni, the head of the 300 program, said it was a compromise between daylight and night image levels. But the interesting thing about this, and the ramp there at Boeing Field where we flew this, was very cramped. And it was really interesting to see, using the cameras, that everybody had moved away from the aircraft. Now, this is a long airplane, and when I taxied, and it was a tight, congested area to taxi, the cameras were helpful, especially since I wasn't used to taxiing a 777 that much. I'd only flew the other one in flight test a few times, the 200, and that had been a while ago. So it was very helpful in that, and it's amazing how close those main trucks come to the edge of the taxiway, like about 18 inches on some turns. And I'll tell you a little bit about that configuration, because taxiing a 777 is kind of an interesting experience, if you will. And one thing about this, okay, we started the engines. You do a control check. The control check, you can't see the wingtips from the cockpit there. You can't visually do a control check, unfortunately, but you do get the sensors on the control surfaces that give you feedback. It's not just they're telling you that the yoke's trying to do this input. It's an actual feedback of where the flight control goes. So you look on the display there, the ICAS, and you can see all the controls move. And yeah, it was very interesting. The nose gear now is 12 feet behind the cockpit. And so you have to do quite a bit of oversteer. You got to go past the centerline taxiway. I mean, the nose is so far past the taxi, and I had a lot of problem with this at O'Hare on the service road there, because you'd be going to taxi out and you'd be going to make a turn. And the roads waiting, the vehicles on the roads waiting for you would think that, oh, you're not turning on this road. They'd kind of wait for you because they don't want to get in the way and get in trouble. But they'd see you go almost by it, and all of a sudden they start going across, and you start to turn. So now you got a problem. We tended to use the runway turnoff lights as kind of a turn signal to give them an indication that we were going that way, but those weren't terribly bright, of course, in daylight. So that was a little bit of an interesting issue. But the nice thing about the cameras was, and I heard that to prevent distractions, flight crews aren't allowed to look at the cameras in flight, but we did. And the neat thing was, you could watch the gear go up and down, see it on the cameras. You could watch the engines conning. You could see the flaperons move and stuff like that. And it was really kind of cool and beautiful color. It was almost, I hate to say it, distracting coming back in when we're coming in to land. One thing. Okay, here's the lesson I learned about flying a large aircraft, because this aircraft is 199 and 11 inches wide, okay, from wingtip to wingtip. And I said, come on, you couldn't throw another inch in there just so everybody could say, yeah, it's 200 inches. 200 feet. 200 inches would be a rather short airplane, yes. Rather stubby, kind of like the Goblin, which was even longer than that. I digress. Okay. Anyway, the 777-300 is 242 feet, 4 inches long. And like I said, a wingspan of 199 feet, 11 inches. And it's got a tail height of 60 feet, 8 inches. And it's designed, the aircraft is typically designed to carry 350 people in a tri-class configuration. Now, when I did the takeoff, I'm taking off, and we got, a little bit of wind, stuff like that, and I'm very active on the ailerons. And I mentioned to Frank Santoni that, boy, there's a lot of turbulence here. And Frank is going, it's you. And I go, what? He says, stop doing this. So I stopped doing that. Turbulence went away. I did this again. Turbulence came back. Okay. So here's the deal. I found out, Frank told me that the 777-300 has a 2.5 hertz lateral structural vibration mode, and the Dash 200 has a 3 hertz lateral structural mode. Well, okay, here's the error I told you about. I was telling my 200 students that the 200 had a 3 hertz lateral structural mode. In reality, it had a 2.5 hertz structural mode. So I was giving out a lot of wrong information. And okay, yeah, that can be an issue. But okay, I was off half a hertz. Hopefully nobody noticed that. But anyway, I learned a little lesson about, big flexible airplanes you can induce. And that's, of course, now I'm going to digress here again slightly. One thing you do in flight tests to determine flutter is you can do singlets, which is just one push, or you can do doublets like that, forward and back. And what you do is you try to excite structural modes in the aircraft. Now, they've gotten good at this. The F-107 was actually one of the first aircraft that I'm aware of that they actually looked at doing ground vibration tests where they tried to excite these structural modes on the ground, which is one thing you try to do. You try to see, because the aircraft will have resonant modes in all sorts of frequencies. You got engines hanging, you got wings, you got all this stuff. It's going to resonate somewhere, but you want to make sure that there's nothing that's going to excite that resonance and get you into a flutter condition, because flutter is just an uncontrolled, undamped vibration, and it's not a good thing. It can be, it can tear an airplane apart in seconds. I've only seen it as a chase pilot once in flight tests when I was chasing the F5E model, but it's pretty exciting when you see it, and I talk about that in other little discussions where I discuss other flight test items, where I discuss chasing the F5E. Alrighty, now back to the flight. Okay, I survived shaking the heck out of the airplane in turbulence, but okay, probably a little bit of a ham-fisted pilot here, so that allows me to evaluate all sorts of situations with the aircraft. And during the climb, I noticed a buffeting during the roll inputs. I was probably being a little more aggressive than I should have been. And the ailerons are typically locked out during climb at 320 knots indicated, and only the flaperons and spoilers are used for roll control. And on the 777, during roll inputs greater than 2 units, the spoilers crack open. Okay, when the spoilers crack open, that's when you get a little bit of buffeting. It spills a fair amount of air, it hits the elevator, and you can feel it in the cockpit as a rumble. So if you've ever encountered that flying the 300, and of course, okay, this was 26 years ago that I was doing this initial flight test. There are a lot more 300s out there. In fact, my airline now has them. I never flew the Dash 300 at my airline because they kicked me out for getting old and decrepit. And yeah, it's age discrimination. Well, whatever. I'm enjoying retirement. But anyway, okay, they kicked me out, so I didn't get to fly it in actual service. But so some of you guys who are actually flying it may see that. Captain Santoni told me when the autopilot is flying, it makes smaller inputs, and so you don't get the rumble. I think he was trying to tell me that I was being just a little bit ham-fist there, I guess. But basically, buffeting is worse on the Dash 300 than the Dash 200. And we went up to the area there, and I got out of the seat for the other people. I'll talk about that just a little bit later, and you can see it in the article. But I was looking at the overspeed compensation, because VMO, the maximum velocity for the 777-300, is 330 knots indicated. I accelerated to 340, and what happens is, as you pass 330, which is the limit, The trim is disabled. I can no longer trim nose down. That's a good thing. I continued at 340 knots, and I had to exert forward pressure on the yoke. When I released the pressure, the airplane pitched back up, and we slowed down to 330. So that's one of the protection modes. And of course, it has the roll mode where you go after 35 degrees. It gives you an input back. It's kind of like somebody's coming on the controls and saying, "Hey, you're over banking, fella. Don't do that." And you also get other warnings. But if you get an upset and you go past 90 degrees of bank, actually you can just release the controls and the airplane will roll out to wings level. And they Boeing has a different philosophy than Airbus. They allow the pilot to over-G, overspeed, and overbank the aircraft. They give the pilot full authority. They don't throw limits in there, other than giving warnings, nudges, making it difficult, making control forces high. But they put little features like when you deploy the speed brake, you get that little bit of a bump that tells you you're deploying the speed brakes. But they dampen out a lot of the things that would to make it just a better flying airplane. You got to get fair off speed when you pull the power at it before the nose starts to pitch up or down. But it does if you go past typically 10 knots or so. We did some stalls. Stalling requires a typical stall requires 90 pounds of force, and in fact, I did some controlled flight in terrain recovery maneuvers, and I'll talk about that in more detail. We did a lot in the simulator. We did some in the airplane. Got a lot of data. It's in a report I wrote, part of the paper on talking about the various flight control systems. But there was a case there in the approach configuration where to get full, I could command roughly 1.6 G, but to get it, it took 135 pounds of backstick. So it took quite a bit of pull. And one thing about the 777 is you got a couple of reversionary flight modes. You got the secondary and direct mode. The direct mode, it flies just like a basic 767, and there's a black guarded switch right above the head. It's not even red or anything. It's just black guard, and you can shut off the primary flight control computers, and it will fly just like typically a 767. And if you really get degraded, it's just not your day. Okay, and I'll talk a little bit about the rat when I talk about that and not having hydraulics and stuff, but it's just not your day. A cable links the yoke directly to a spoil panel on each wing, and the pilot has direct mechanical control of the hydraulic actuator in the stabilizer through the yoke. Numerous times during this flight test, we cycled back and forth between the normal and direct modes and just looked at the various handling characteristics of the aircraft. And in Dutch roll mode now, I let Steve Stowe get in the seat here, and he looked at because his even more extensive flight test background than mine, obviously being commandant of the test pilot school. I was never commandant of test pilot school, but he was, so he knew what he was doing. And he looked at the Dutch roll in direct mode, and it takes typically in direct mode where it flies like a normal airplane. It took 4 cycles to dampen out, and it has a high roll to slip ratio. Let's see. The stalls were kind of interesting here. There had been an interesting event with another pilot that had flown the aircraft previously. You don't want to use rudder during the stalls. Now, okay, most people, you're never going to get into a stall typically unless you really screw up. And we're not talking about stall warning. We're talking about full buffeting in the stall. We went into the stalls. And this takes the flight test component. We had like 20 flight test engineers on board, because when you go into stall, you can get a lot of buffeting, a lot of disturbed airflow, and it goes back and it hits the tail there, and it can impart some very serious loads on the tail. So they're back there watching the strain gauges, and they can call terminate if the loads are getting out of hand. So it's very interesting. They're right there, in our ears, And they also have cameras in the cockpit looking forward so they can see what's going on in the cockpit. But one of the pilots got a little bit out of phase with the rudder and ended up going over 90 degrees, which I think John Cashman was the one who was flying with him, and he says, yeah, it kind of gets your attention, and it certainly got his attention. Of course, John's seen a lot in flight test on these airplanes, so it wouldn't have been too much of a surprise factor for John, but I'm sure the other guy, it really got his attention. And the one thing about the stalls in this aircraft, it's a very pronounced vertical vibration. I was in the jump seat while they were doing the stalls. We did clean, we did a bank turn, we did dirty configurations, and I thought I was pretty well strapped into the jump seat, but I actually was coming off the jump seat during the stalls. So it's interesting. And other things they put in there is you need a column disconnect force of 15 to 20 pounds to override the cockpit, autopilot. So what you don't want is to be flying and bump the yoke and inadvertently disconnect the autopilot. Of course, you typically get the warnings, but that you don't want to disconnect it inadvertently, and that's led to issues before when they didn't have a high load. Now, if you're going to do a Cat 3 triple redundant approach, you're up to 60 pounds of force necessary to take the autopilot off, because that's a case where you really don't want to have an inadvertent disconnect. And it's kind of interesting during the stalls. Depending on your flap configuration, not all of the slats are out, but to help you with the stall once you've entered it, they automatically extend the slats. Now, this aircraft has demand pumps, and they're useful on takeoff and various configurations, and they're run off the air system, off of bleed air, these demand pumps. And what happens is if you actually get into a stall, to have increased hydraulic pressure, because you're running a lot of stuff out and you want to run these slats out quickly. The air conditioning packs actually are momentarily turned off, so the pneumatic hydraulic pumps can have actually more power. So that's kind of an interesting feature. I mean, this is a well-designed aircraft. These guys absolutely thought of everything. And it's interesting. We did a lot of touch and goes, and Frank Santoni would pull the one of the engines back to simulate a V1 cut. And of course, like I mentioned before, the airplane flies much easier than the simulator ever flies. And it was kind of funny. We had been doing a bunch of touch and goes, V1 cuts, and stuff like that. And Frank pulled he meant to keep the fuel balance. I mean, you can always balance it and stuff like that. But he was just adjusting the thrust. We'll just cut this engine one time. We'll cut the other engine the other time. And of course, it's always you always want it to be a surprise. So we can have a true reaction. So okay, he pulled one engine, and he decides, oh no, I wanted the other engine. So he puts the engine he pulled back up real quick. I'm already starting to climb out. He puts that engine back up and he pulls the other one back. So I called it, or Terry Lutz actually behind me called it a double V1 cut, because the tack, which automatically puts in rudder, it leaves you just a little bit so you get a feel that, yeah, you've had an engine out. But it went from 10 units left trim right to 10 units right trim. I just felt the rudders moving like that. So it was kind of cool. Now, some other little factors on the 777. The 200 has an MMO of 0.87 Mach, and this is kind of interesting. You do a lot of effort to design an aircraft well, but the performance engineers didn't quite get it right. They thought they were designing a 0.82 aircraft, and actually the thing, as anybody flies it, it's not a 0.82 aircraft, it's a 0.84 aircraft. We all fly at 0.84. Well, one thing they did was they'd always be in a hurry to get from like Renton or Boeing Field up to Moses Lake to do work, so they'd John Cashman said, we're always going fast. Well, they found out that the thing actually cruised better at 0.84 than it did at 0.82. So, yeah, that's cool. So it's up to 8.4, but of course, with your Mach limit of 8.7, you're kind of close to that. So you gotta kind of watch out for that overspeed. And the guys went up, and we looked. We took a little bit look at the overspeed. Like I said, if you're a glutton for punishments, you can read my article. Now, my turn to get back in the seat here, and we wanted to look at the ram air turbine, because the ram air turbine is located behind the right main landing gear, and it can provide both electrical and hydraulic power. Um, the we deployed the rat, and it's kind of interesting. We didn't hear it, but the flight test engineers back there, who are more located more where it was, said, "Yeah, that thing's pretty loud." And once it takes just a second to deploy. So if you're in a bad situation where you lose those engines and stuff like that, you're going to be just a second where it's deploying, because it's got to come down, and it's got a big spring. You do not want to be in the way of this, like on the Airbus. If you inadvertently deploy the rat on the ground, you could kill somebody. So you don't want to do it, because it's made to come out quickly. So there's a big spring there. You want to stay out of the way. That's why they usually put a little red box around it, and the guys know to stay away, because passengers don't go walking out there. So that's not a problem. I digress. Anyway, when the rat is up to speed, then Frank took and he shut off the center, the right, and the left hydraulic system. So we're only flying on rat power. And we were about 280 knots, and the control response, obviously, where you just got this little thing, and I'll show you a picture of it here later, where you just got this little thing powering you, and it's doing hydraulics and electrics. It's not going to be as potent as you want. And so the airplane's a little sluggish. For roll control, we had the right flapper on, 2 spoilers on the right wing and 1 on the left, and we had the right elevator. So, you've got reduced flight control, so you're not going to be performing loops or anything. It's going to get you back safely. It has the ability, just that one little guy, to power you and get you back. And of course, the APU has his, depending on the situation, it will automatically start and stuff like that. So, the interesting thing is the rat doesn't have enough power to extend the flaps hydraulically. So, of course, as long as you have electric power, you can get them down electrically. But if you don't have electric power, you're going to be doing a no-flap landing, and basically you're coming in at VREF plus 50 knots. So you're coming in pretty fast if you have to do that. And I could see that by being aggressive on the controls, that I could take the hydraulic pressure from the normal 3,000 psi down to 1,000 psi. So again, you don't want to be ham-fisted here. But hey, we had a great flight. 4 hours, 42 minutes. We consumed 72,800 pounds of fuel, and Boeing was very, very generous. They let us get a lot of good flight test data. They let us get flight test data for the work I was doing on controlled flight into terrain. And yeah, it's not the situation with Boeing now. But of course, I left the committee early 2000, something like that. I forget. Terry took over. It wasn't too bad for a while, but of course now the relationship between Boeing. In fact, I heard that Boeing had a bad relationship with ALPA, or ALPA had a bad relationship with Boeing, and I'm going, what? We had a great relationship with them. They were very open. I was allowed to see a lot of proprietary information. I was left in the vice president's office with a book on the work they had done. Well, I won't go into too much details on that, but they allowed me a lot of freedom to go deep into a lot of information that Boeing held very, very close to the chest. And Boeing did a little evaluation of what they call the small displacement controller, not a side stick. And part of the issue on this is, to do the protections the way they wanted to do it, you really needed a yoke. And I talked to Airbus quite extensively about this, that how you would implement soft protections. Hard is the pilot can't override it. Soft is, yeah, you can. Well, how do you do the soft protections on a side stick, because if you come back and you have like a ramp feature where you come back so far and that ramp is telling you, okay, the force increase, that's the whole ramp thing, the force increases, so you come back to that point and now you want to pull more. Okay, well, the airplane says, well, you're at the limit. We don't want you to pull more, but you want to pull more. So you pull back to that ramp. Well, they actually evaluated this in the F-16 and that. NASA did some studies, and I was trying to put together a program on it. But basically, they found that when you came back to that ramp, most pilots thought they had reached the maximum control deflection, and they didn't pull through the ramp into the greater area of authority. So they found out there wasn't really a good way to implement soft protections on a side stick, just because the displacement was small, and the forces were relatively high. I talk about that in some other things I talk about when I talk about the side sticks and the yokes and stuff like that. I know I enjoyed the side stick on the Airbus when I flew them. I enjoyed having a tray table where I could put my meal right in front of me. But I enjoyed flying the 777 too, with the yoke, and the handling qualities, the characteristics were great. So, they both work. They're different design philosophies. Airbus has proven that, its concept works fairly well. There were problems in the beginning, and there are still some issues. But there's not an airplane been made yet that a pilot doesn't know how to crash. Now, okay. That's kind of going through the article a little bit. I got some extra little pictures here. This is our committee members walking around below the aircraft there. This is our flight test aircraft. Before we go up and fly, I took a few pictures. That's me and Terry Lutz. That's the door to the cockpit, and of course it's a Rolls Royce, and Terry, of course, was the one who took over from me on the committee. That's me in the left seat getting ready to go on the test flight. And you see those little numbers. I always get this backwards. Right down there. And the other on the glare shield. Those are all flight test items. You can put a whole bunch of stuff in there, like stick force per G. You can put in the deceleration. That little meter there right below me actually will show acceleration, deceleration in 1 knot increments. And there's Steve Stowe in the simulator when we're doing some of the CFIT work. There's Terry Lutz next to him, and Frank Santoni is a little bit behind him, and I'm taking the picture, of course. And there are our flight test engineers in the flight test stations, and you see there's quite a few of them back there. I kidded Boeing. I said, you got to put more seats on this or you'll never make money. And there's the deployed ram air turbine. Fairly good size there. That's on the left is Terry Lutz. Joe Kohler there is in the center. And Steve Stowe is on the right, and I'm the one taking the picture. And there's, just to show you what it looks like when you open the cowl, that's access to the engine there. Now the tail skid. Okay, this is a long airplane, and they were really worried about tail strikes. So they incorporate a protection and an indication system if you hit the tail strike. Also, after your takeoff, you'll get a printout on your rotation rate and your pitch attitude on takeoff, so it kind of tells you if you're doing a good job or bad job, because you can hit the tail on takeoff or landing. I think if you're ham-fisted on takeoff and rotate too fast, or I hear it's gone now, but if you're taking off on the ones at San Francisco and they had a little bump on the 28s, and the 27 with flaps 15, it would just about rotate about the time you hit that bump, and if you weren't careful, you could hit that tail skid. So you had to, on the 27, rotate, but not too much, get over the bump, and then you could continue the rotation if you were heavy, or try to take off before it if you could. And there's a depiction of the tail skid that extends in landing once the gear's down. And there's a diagram of various margins on the tail skid when you actually strike the tail, and what you should have for a normal pitch attitude at touchdown. And these are conditions. This is the takeoff condition, and this is the landing condition. And just for the interest, there is a comparison of the gear position. 777-200, it's 84 feet back. 300 is 102 feet back, and the 400 is only 84 feet back. And there is the control panel for the ground maneuvering system there. And cameras can be displayed on any of the shaded, either the navigation displays or the multifunction displays down there can be displayed. And I wish I had a picture of an actual presentation. I didn't get one, unfortunately. But basically, you can see the nose gear and you can see the main gear and the engines. And like I said, it's fun to watch the gear extend and retract. And there's some more information on the ground maneuvering system and basically the view range of the cameras. And there's me. You know, as a pilot, you always like to have your hand on the propeller there in front of your airplane. Of course, this isn't in front of it; it's in the back. But anyway, that's me standing there, young guy with not this color of hair, with a hand on the propeller. So that was my final flight out of Maui. I was 13 years on the airplane. Had about 8,000 hours or so on it, and thoroughly enjoyed it. Actually, I'm in the process of getting some shirts made up with this rainbow on it that I think are going to say, "May you have blue skies always," something like that. Anyway, hey. I know it's been a little long, this one, but hey, if you stayed to the end, thanks for watching. Appreciate it. Take care.